Reducing arrival variability. When we discussed the queuing models, we said that average waiting time depends on 3 factors, and one of those factors was the variability factor, and variability factor combines arrival variability and service time variability. And it basically says that if you reduce one of those variabilities, or both, you are going to reduce the average waiting time. So it only makes sense to try and think if we can reduce arrival variability in order to reduce the average waiting time. One idea to reduce arrival variability is to use an appointment system. Instead of customers arriving at any time they need a service, we might provide them with an appointment system, right? So a customer can call, get an appointment at a particular time on a particular date, and then they might get a better, shorter waiting time, because when they arrive, they may need to wait just a few minutes, or even there might be no waiting at all. An example would be a dental clinic where customers are given 15 or 20-minute appointment times, or maybe half an hour or 1 hour, depending on the duration of the service that they need. Unfortunately, these systems do not really eliminate all the variability. So customers will still arrive late, and then when they arrive late, their service might overlap with the appointment time for the next customer. There also might be no shows, and then you have idle time for the server when you could actually have a service for another customers who would happily come in, right? And they also so somehow we need to handle these circumstances, right? But they are usually difficult to implement. So, for example, charging extra because you arrived late would be probably perceived negatively by customers. But one example of a good way to handle no-shows is to have a reminder for customers to about an appointment, and maybe request that they cancel in case they are not going to use the appointment, or even some companies will call each customers. These are important services, like, for example, surgeries, right? When you have a very high cost of resources, or booking a surgery room and doctors. If somebody if in case somebody would not show up, this would create a lot of cost. So it's much better to call every customer a day before and make sure they will be arriving. It also creates problems with reserving capacity for last-minute cases. So let's say in the case of the dental clinic, you might always have customers who arrive, who need an urgent appointment, and they cannot wait 1 month or 1 week because they have a toothache, for example. And also the biggest problem actually is that the reduction of variability is not complete, because you have, yes, indeed, you have less variability in arrivals as seen by the operation. Customers who come, they come when they have appointments. But in fact, the variability of the true underlying demand is not reduced, right? And this can be seen if you observe distant appointments. So, for example, if I call my dental clinic today and they tell me they can give me an appointment in 1 month or 2 months, right? Then I actually know there is a lot of demand, and I am experiencing a lot of arrival. The system is experiencing a lot of arrival variability, perhaps, and now there is a peak in demand, right? And I still have a lot of waiting. It's just that the waiting is not in this clinic itself, me sitting there on a chair, but I wait outside of the system for a very long time. Even if this, more acceptable waiting, sometimes it is not, right? I might shift to another dental clinic because of this long waiting time from now till the requested appointment. So a good appointment system should not only observe the inventory of customers waiting in the service itself, the system itself, but it also should observe waiting line of these long waiting customers outside of the service system, those who call now for an appointment, right? Another way to reduce arrival variability is to provide incentives to avoid peak time. examples would be, early bird specials at restaurants or bars. Come early at 6, at 7 p.m. Drinks are 20% off, or maybe in a restaurant when we know there are some times when the people don't arrive early for lunch or dinner, we might offer incentives. We could offer price discounts in hotels during off-peak days or seasons. The same thing in transportation, public transport. Let's say you can offer full day, 1-day tickets for all public transport in a city that, for example, is at a certain price for full day, but if you use it only after 9:30, which avoids the morning rush hour, you might have a much lower price for the 1-day ticket after 9:30, right, in the morning. A similar thing happens in air travel, where pricing is used sometimes to discourage booking travel at times or days when we already have a lot of demand, right? So then, if there are some days where there's already a lot of reservations for travel, for air travel, you might have a higher price to get the ticket. Actually, the first three examples here, the early bird specials in restaurant and bars, and the hotels, or the pricing discounts in hotels or in public transportation, are actually ways to reduce seasonality, right? Because we said we know certain times or days are already with lower demand, and there are later or at other times there's higher demand, and we are trying to shift, right, customers from higher demand time periods to lower demand time periods. And this, of course, right, this actually reduces seasonality. However, it still helps reduce average waiting time, because if we shift some customers away from, let's say, morning rush hour in public transport, right? If there is fewer customers traveling at the morning rush hour, then we even though this is not arrival variability that we reduced, we flattened more the seasonality, the seasonal variability. The demand for rush hour will be reduced, and therefore the service during the rush hour will be of better quality.